Why don't you pause the video and read through this particular problem? Before we start this, let's think about how it's different than what we were doing before break and in the video from Monday. In this example, we have paired sets of data. We have 12 sets of twins, and each twin is being split into two different groups. One twin is watching a comedy while the other twin watches a drama. We are deliberately pairing them up because we have a set of people who are as close as possibly they could be. We're being deliberate about the way we put people into the two groups. This is a paired test because we have paired up people and split them up. Before we do this example, let's just really quickly look at some examples so we can practice identifying which of these are paired t-tests and which are two-sample t-tests. We're actually going to work backwards here. We're going to start with C. So pause the video, read through C. Now in this example, it's kind of like the twin example. We have couples where we have a female and a male partner, and those two people are paired. We're measuring their responses, and we want to figure out how much the men and women differ on this scale. Since we deliberately have them paired up based on their relationships, this is a paired t-test. We didn't just pick 40 random males and 40 random females, and now we're comparing the difference between males and females. We've deliberately paired each male to female, which makes this a paired t-test. Now in B, why don't you pause it and read through B. For this one, each person is paired with themselves. A paired test can also be you're pairing yourself with yourself. You have like a before and an after score. For this, each subject is working with and without music, so they are paired with themselves. So this is once again a paired t-test. Now pause the video and read part A. In this example, we have cars with brand A tires and brand B tires. We have not deliberately paired each car with a similar car. All that we've done is we've taken 50 cars of the same make and model, randomly assigned them either A or B. This is a two-sample t-test. This is what we were doing in the video from Monday. Because we haven't deliberately paired up the cars, we just have two completely separate populations that we're comparing. If you have deliberately paired people or things, you're doing a paired t-test, which actually is just like what we did in the previous chapters. Or I should say a paired t-interval. It doesn't have to be a test. It could be maybe you're estimating something instead of testing something. But either way, it's more like a one-sample test than a two-sample test. So let's go back to this example with the twins. We've got the number of ounces of soda that they drank while watching a comedy versus a drama. So here I have the results. So you can see here's comedy, here's drama, and then here's the difference. And highlighted here we can see we were doing comedy minus drama. We've got the mean for comedy, mean for drama, and the mean difference, the standard deviation for each group, and there are 12 twins in each group. So the way this was calculated was each set of twins, we took the comedy number of ounces minus the drama number of ounces, plotted that over here, and then all of those differences, we calculated the mean and the standard deviation. All right, so let's get to the actual test. Okay, we're going to start with the state step. Since we're doing a test, we need a null and we need an alternate. Now we don't have two populations here because this is a paired test, so I only need a single mu. I'm not doing like mu A minus mu B, I'm just doing mu difference. The question is, what should our null and alternate be? We're supposed to be finding if there's evidence that the genre influences how much soda people drink. So the null would be if that wasn't true, if the genre doesn't affect how much people drink, which would mean the mean difference between the two genres would just be 0. There's no difference between the two genres, doesn't matter what you're drinking, or what you're watching, sorry, you're going to drink the same amount no matter what. Now, they don't ask if like comedy makes you drink more pop or if, soda. Sorry, soda. I don't want to offend anybody, it's not pop. They don't have a suspicion that one is worse or better than the other, which means our alternate is just going to be that the mean difference is not equal to 0. And this is abbreviated. If you were doing this for real, you'd want to write out mean amount of soda drank while watching a comedy, mean amount of soda drank while watching a drama, but for now I'm just going to keep it short and simple so that this video isn't too long. Alright, next up we have the plan step. Now random, the twins weren't randomly selected, but they were randomly assigned to the 2 movies, so that's okay. As long as one of those things is random, you should be fine. The randomly assigned to the 2 movies is pretty important so that it's not, we don't have bias, like this, they're not getting to choose. If they got to choose, then you might have bias because the twin who likes comedy gets to watch comedy. So it is important that they're randomly assigned. For normal, our sample sizes are only 12, but you can see on this distribution, it doesn't look like we have any outliers. Maybe this twin, this set of twins, but mostly it looks like there's no outliers, so we'll proceed. And then for independent, just the same as usual, we have to assume that there's at least 120 sets of twins. I think that's a safe assumption. Alright, now as I previously mentioned, this is a paired t-test, and we're going to say for the mean difference. Not difference of means, it's for the mean difference. The book mentions that you can say this another way. You could call this a one-sample t-test if you want. I kind of like saying paired t-test because it's making your brain think about, like, did they intentionally pair up people in these 2 samples? Now we get to the do step. So we are doing a test, which means we need a test statistic, either a z or a t. Since this is means and we don't know the true standard deviation of the population, it's going to be a t-test, so we need to find our t statistic. Alright, now we only have 1 sample, so we don't have to do all the differences. We're just going to have x bar difference minus the mean difference over, and if you've forgotten standard error for one population, here's means, here's one population, here's the standard error, it's just s over root n. Totally fine if you've forgotten that, it's been quite a while. Alright, now we plug things in. Okay, we get a z-score of negative 0.88, or sorry, t-score, my bad, of negative 0.8845. That's not too far away from the mean, so I'll put it right here. Our alternate was not equal to, so I need to find the area of this tail and multiply it by 2, because not equal to could be more extreme in either direction. We're using TCDF. Degree of freedom, we're going to use 11, because our sample size was 12. Alright, so after multiplying by 2, we get a p-value of 0.3953. And now to conclude, the probability of getting a mean difference of negative 0.708, or something more extreme if the null were true, is 0.3953. This is much larger than our significance level of 0.1, so we fail to reject the null. We do not have convincing evidence that the type of movie influences how much soda people drink. So, you might be thinking to yourself, this seems like we've done it already, and the answer is yes, you have done this already. In the old version of the book, this concept of a paired t-test was actually back when we did confidence intervals and significance tests for means. In this version of the book, I think they moved it here because students tend to confuse it with a 2-sample test. So I get why they moved it. It's also a nice review, I guess, of a 1-sample t-test. But the thing to think about when you come to these types of problems is, like in this example, were the people deliberately paired and split into 2 groups, or like in part A, were there 2 separate populations that we're testing? Once you figure that out, you get to decide, am I really doing a chapter 10 problem, a 2-sample test, or am I doing a chapter 8 or 9 problem, a 1-sample test?